here. So please pay close attention. I hope I am properly audible and my audio is not breaking, correct? बोल भी सकते हो. Am I audible properly, guys? Okay. See, today we will start recursion. But again, remember, just because we have moved to recursion doesn't mean that whatsoever we have discussed previously will not come into picture. For example, array problems, okay, they are going to be there all the time. So like tilt tree, graph, segment tree, we will go there. It will take some time for us to go there, probably a month, but then array is going to be involved almost everywhere. From data structure perspective, we have looked at one more data structure, hash map. Okay, so again hash map is going to be involved in lots of problems that we are about to discuss. Then from problem solving perspective, we have discussed things like two pointer, then we have discussed about sliding window protocol, then we have discussed about binary search, then we have discussed about prefix suffix approach, and so on and so forth. So all of these things, one way or another, they are going to be involved in some of more problems that are yet to come. Why I am discussing recursion here? Because there are certain problems of arrays, there are certain problems of strings, and also remember one thing, whatsoever we have discussed with array, the same thing can be applied with a strings also in the same way. Both are like a sequential data structure only. The only difference is how we access elements. For example, if I give you an array, you and then if I ask you to access, sorry, things that is present at index 1, you might be writing it like this, correct? In Java, let's say that if I give you a string and then this string has some content, and if I ask you to access element at index 1, the same thing you will do like this, str.char at 1. So instead of using indexing like this, you will have to invoke a method caret like this. If you are someone who codes in Python, then in Python it will be same as we use with array. So it's just access of data changes, and from problem solving perspective they are almost same, array and a string, but of course internally they are totally different. The way they are represented in memory, they are different, they have different mechanism, and so on and so forth. So we will move into recursion. Now here, till now whatsoever code we have wrote, for example, you look at some of the codes we have discussed, and also we have started our discussion of bit manipulation, so that will keep on going. Okay, it's never going to end, anything is never going to end. So here please have a look. When we wrote this particular code, when we solved this problem to unique.java, okay, so we were given an array and it was said that there are two unique number in this array, find out that unique number. So you see we are writing functions, so there is a separate work that needs to be done. If I wanted, I could have done that same work here also. Instead of calling a different method, we could have done it here also, but then we are writing a separate method. Method or function, they both are same. Okay, so I will be using these words for one another every now and then. So whether I say method or I say function, they are both same. The only difference is method is a function associated with some object, and since Java, in Java nothing can exist without a class, every function is by default a method. Okay, so in Java, have you ever heard anyone saying main function? We always say main method. Why? This is just a normal function itself. Okay, a function that is accepting some argument, doing some work, as simple as that. Okay, the only difference is since this function cannot exist without this class, that's why we are calling it method. But then if you talk about languages like Python, in Python we can have a function without a class, so there we will call it function. But we can also have a function with class. So the same function will be called as method. Same happens in JavaScript also. You can have a function inside a class and you can also have it outside of a class. So when we will have it inside class, we will call it method. When we have it outside of class, we will call it function. Okay, so method is just a function that is associated with some object. It's just you needed to know it. So here we wrote some method, or I will keep on calling it function only. So we wrote some function to do some separate work. Okay, with functions there is a very interesting event that might occur. For example, here main method is calling this function, correct? Get first set bit pos we have called inside main method. Then this function again get ith bit we have called it inside main method. So the point here is you can call any function inside any function, that is totally on you. Here we had the need to call this function, that's why we called it. Same goes true here also. Here we had this need to call this function, that's why we called it. Now this gives birth to a very interesting scenario like this. Okay, so let's say that there is a function. Let's name. Now this function can call any function. Let's say that there is another function f1, there is another function f2. Okay, here so this f can call f1, yes of course it can call. Can it call f2? Yes it can. Same goes here, can this f1 call f? Yes it can. Can this f1 call f2? Yes it can. So if they can call anyone, this function it can call itself also, like this. Okay, no matter what is the work we are doing, but then let's say that there are few lines and in between somewhere we have something like this, or plainly we might be having something like this also. This is my whole code. Okay, so whenever a function calls itself, this event in programming term we call it recursion. So recursion is nothing but an event where a function calls itself. Okay, function calls itself. Now because of this, if you pay attention at the simplest version of this event, the simplest version, it might look like this. So there is a function f. In this function there is a single line that is nothing but making call to itself. If you look at it, you will realize that this code that you see here is an infinite loop. It will never stop its execution. So if I call this f for the first time, this f will do its work. What is its work? Its work is calling f again. Then again this call will call f again, and so on and so forth. It will keep on calling itself. So with recursion, there are couple of important things that you need to take care. First, you should have a base condition to break your recursion. For example, instead of writing this code like this, if I write it like this, f, it is receiving some argument n, and then I am saying that if my n value is less or equals to 0, then you please return. You do not need to do anything. Otherwise, can you please call f of n minus 1? Okay, now look at this code. Sorry, let's just write f of n plus 1. Okay, look at this particular code. Remember one thing, you can use return like this also. For example, here if you look at this particular method, it is returning answer, but can I use return a statement like this also? Yes we can. It is going to produce error because the method is expecting you to return void, but you are return int, but you are not returning anything. The moment you change it to void, you can also use a return a statement like this. Now next point here is return returns two things. If I write something like this, return 3, it is this statement when executed, it will return two things. First, the value that you are returning, so the value that you are returning, and second, control of execution. The moment this statement gets executed, control of execution will also return. What it means, that let's say there is a function f, this function has called f1. Now f1 is executing, suddenly somewhere in between it has executed a return a statement, and then there are couple of more lines. Now because of this, what will happen, these lines will never get executed. Why? Because the moment you executed a return statement, control of execution also gets returned to the caller. Okay, so f1 will not able to execute itself. When I use return like this, in this case only control of execution will be returned. Since there's no value, no value will be returned. But of course we will not torment this code, let it be like this only. Now come back to our original discussion. Okay, so here we have used return a statement like this. It simply means that control of execution will be returned. Now first thing with recursion, you should have a base condition to break that recursion. Now this is alone not sufficient. You see, this code can still fall in infinite loop. If I call it with a value greater than 0, for example f of 1. Okay, so f of 1, is my n value less or equals to 0? No, it is 1. So this line will get executed, it will call f of 2. Okay, n plus 1, n value is 1, 1 plus 1 is 2, so f of 2 will be called. Similarly, is my n value less or equals to 0? No, so it will call f of 3. Now this is still an infinite loop, it will keep on going. Loop doesn't always looks like this. Okay, this is also an infinite loop only as long as we do not have any point of break to this particular call. Okay, so you see it will keep on going, and somewhere you will encounter something we call a stack overflow error. Okay, it simply means that whatever memory was allocated for your program, 500 MB in most of the cases, you have exhausted the memory and we do not have much memory to make the next call. Okay, so first thing with recursion is you should have a base condition to break your recursion. Second, you also need to make sure that your recursion is written in such a way that no matter with what value I call, it is always going to hit the break condition, the base condition sometimes. For example, the same thing if I write it like this, that print n, and then after that can you call f of n minus 1 instead of plus 1 if I call n minus 1. Now this code that you see here, no matter with what value you call it, it is always going to break. If I call with a value less or equals to 0, for example 0, it will break immediately. F of 0 will start its execution at line number 1 itself, it will be done. If I call it with a value greater than 0, for example let's say if I call it with f of 2, so again, is my n less or equals to 0? No. So it will go to this line, it will do some work, and then it will call f of 1, n minus 1, so it will call f of 1 again. Is my n value less or equals to 0? No. So it will do this work and it is going to call f of 0, and here it will break. Remember, with recursion there are two things that you need to be aware of. First, you should always have a base condition to break your recursion like this. Second, your call should approach this base condition. For example, this case, it should approach this, it should not go away from it. This is a condition where my recursion is going away from my base condition. Okay, this is a call where my recursion is moving toward my base condition. So two things, you should always have a base condition to break your recursion. Second, your recursion should approach that base condition instead of going away from it. Now, once you have understood these two things, the next thing that I don't think you will be having any doubt in this. Okay, it's just technically I wanted to talk about these things, that's why I have talked. But then still, is there anyone who is having any doubt? Please feel free to mention, and if you do not have any doubt, then also you need to say no doubt, sir. Is there anyone who has any doubt, guys? Okay, just a minute. Okay, so here next thing that you need to know is how to trace a recursion. Okay, for example, if I come to you and I give you a recursive call like this, so let's say there is a function f, this function goes something like this. So if my n value is less or equals to 2, in this case I will return. Otherwise what I will do, I am going to print n, then I will call f of n minus 1, or let's say n minus 2, then again I will print n. Okay, let's say that if someone comes to you and they tell you that for this recursion that you see here, tell me what is going to be the output if I call it with f of let's say 5. Okay, now remember one thing, whenever a function gets called, okay, for example here in this code we have called this get ith bit, or here a little bit above we have called this particular method get first set bit pos. So whenever a function gets called, the only thing that happens is every line that is written inside that function will be executed, every line. So the moment someone calls get first set bit pos, that call will only do one thing. What is that thing? It is going to execute from line number 22 to line number 27, line by line. So same happens true here also. The moment you have called this f of 5, it simply means that for this 5 I need to execute these 4 lines. Okay, there are 4 line of code inside this particular function, I need to execute it. So let's try to execute it. These are the 4 lines that we need to execute. We will execute line number 1. If my n less or equals to 2, is my n less or equals to 2? No, so nothing will happen. Line number 2, print n. So n value here is 5, so 5 will be printed. Line number 3, call f, and we are done with line number 2 also. Line number 3, call f of n minus 2. So this function, it is going to call f of 5 minus 2, okay, which is nothing but f of 3. It is going to make a call for f of 3. Now you see, line by line I said. So once we are done with line number 1, then only we will go to line number 2. Once we are done with line number 2, then only we will go to line number 3. So line number 3 is currently in execution. Okay, so we will wait. Before we execute this line number 4, we need to completely execute this f of 3. Again, no matter who calls the function, I call the function, main method call the function, or function calls itself. Whenever a function is called, the only thing that happens, everything that is written inside that particular function will be executed. So for this f of 3, again we have to execute these 4 lines of code. So this 4th line will be executed only when we are done with all of these. Call for f of 1, okay, f of 1, and then this line number 3 is currently in execution. This line number 4 will wait. We will come here again. For this f of 1, we were supposed to be executing these 4 lines. Okay, now in this case line number 2, 3 and 4 is unreachable. Why? Because we will go to line number 1. If n less or equals to 2, yes, this time my n is less or equals to 2, so we will execute a return statement. The moment you have executed a return statement, it will return you 2 things. First, the value. Since there are no value, in this case null will be returned in Java, none will be returned in Python, and I don't know what's the scenario in C and C++. Okay, you can check it. But since so I will execute line number 1, and control of execution will immediately return to its caller. The moment I came back here, I am done with line number 3 also. Then we will move forward. Line number 4, print n. N value is 3. So we will print 3 here. Okay. We are done with line number 4 also. Now think about it. Control of execution from a method can return in two cases. First case, either you execute a return statement. That happens with f of 1. F of 1 was supposed to execute 4 lines, but line number 1 asked it to execute a return statement. That's why control of execution return. Second case where control of execution can return is when you finish your execution. For f of 3, we have never executed a return statement, but we have executed every line. So once I am done doing my work, I should go back to my caller. So control of execution can return in two cases. First, either you execute a return statement or you completely finishes your execution. F of 3 completely finishes its execution, so it will go back to its caller. Okay, f of 5. The moment I came back to f of 5, I am done with line number 3 because line number 3 was asking me to execute f of 3 completely. Then we will move forward. For print n, n value here is 5. So 5 will be printed again. Okay, and we are done with executing all 4 lines of f of 5. So by that time, these are the 4 values that are printed on the console. Correct. So if someone comes to you and asks you that what is going to be the output for f of 5, this is the output. We will be having these 4 integers on my console, and you have understood the base procedure. I mean, this is what happens internally, how it is happening, what are the data structures that are used to support this thing. We will talk about it later. For now, is this understood to everyone? We will take a couple of more examples, but then if you have any doubt in one go, please feel free to ask for help. Anyone, any doubt for now? Okay, so if you do not respond, then I will just assume that you do not have any doubt. Okay, now let's quickly have a look at one more example, and then we will move forward with something we call faith and expectation in recursion. Very powerful concept. We will be starting with very small code examples, but then before that, let's quickly have a look at one more recursive call. Let's say that if I come to you and I give you a recursion like this. Okay, so if my n value is less or equals to 2, please return. Otherwise, please make a call to f of n minus 2. Then let's say make a call to f of n minus 1. Then let's say print n, and after that let's say make a call to f of n minus 3. Okay, so very hectic call. If someone comes to you and they ask you that tell me what is going to be the output if I call it with f of 4. Okay, again it might look very complicated for you, the recursion. If you go and try to make some prediction about it, you will always do it incorrectly. Okay, so very simple, although there exists a faster way to trace it also. We will talk about it. For now, let's learn what happens internally. So long story short, there are 5 lines of code. We need to execute these 5 lines. Okay, 1 2 3 4 and 5. So let's quickly go and try to execute it. If n value less or equals to 2, no. So we are done with line number 1. Line number 2, call f of n minus 2. So it is going to call f of 4 minus 2, which is nothing but 2. Now again we are waiting here. This line number 2 is waiting to complete its execution so that we can move forward and execute 3 4 5. Now again for this f of 2, there were 5 lines of code. Okay, line number 1, if n value less or equals to 2, yes, it is not less but it is equals. So line number 2 3 4 5 is unreachable. We will execute line number 1. We will execute a return statement. Control will immediately return. The moment I came back here, I am done with line number 2. Now line number 3, call f of n minus 1. So it is going to call f of 3. 4 minus 1 is 3. And again we are waiting here. Now f of 3, we were supposed to be executing these 5 lines of code. Line number 1, if my n less or equals to 2, it is not less or equals to 2, nothing will happen. Line number 2, call f of n minus 2, so it is going to call f of 1. N value here is 3, n minus 2 is 1. F of 1 will return without doing anything, okay? So line number 1, f of 1 will execute line number 1 and it will return. We are done with line number 2 also. Now line number 3, call f of n minus 1, it is going to call f of 2. Again, f of 2 will also return without doing anything. It will execute line number 1, condition will hold true, and it will return without doing anything. Okay, so we are done with line number 3 also. Line number 4, print n. What is n value here? 3. So 3 is the first value that will be printed. We are done with line number 4 also. Line number 5, call f of n minus 3. So it is going to make a call for f of 0, and f of 0 will also return without doing anything. Why? Because condition will match, and then we are done with line number 5 also. Now f of 3 completely finishes its execution, so it will go back to its caller. Okay, the moment I came back here, I am done with line number 3. Now line number 4, print n. N value here is 4, so 4 will be printed. We are done with line number 4. Line number 5, call f of n minus 3. N value is 4, n minus 3 will be 1. It is going to make a call for f of 1. F of 1 will return without doing anything, and then we are done with all these 5 lines. Okay, so from today onwards, this is going to be the output. If you wish to verify it, let's quickly verify it also. So here I will just go here, then let's create a file, recursion.java. Just a moment, okay, we will not have much time consumed here. Let's have our main method. Let's have a value n equals to 4, and then let's make a call to a function fun, and this function will look something like this: public. You can also have it private if you want, since you are using it in the same context, but it needs to be a static. It is not going to return me anything. The name is fun. It will have a n, and then how the call goes, if I remember it correctly, if n less or equals to 2, then you please return without doing anything. Otherwise, what's happening here? N minus 2, n minus 1, print n minus 3. Let's make a call to n minus 2, then n minus 1, then print and n minus 3. So fun of n minus 3. And if I call it with n equals to 4, if I call it with n equals to 4, what is the output I am expecting? 3 and 4. Let's quickly verify it. Wait for a moment. Correct, 3 and 4. So from today onwards, if someone gives you very a small recursive code and then they ask you to trace it, please do not panic. Of course, there exists a better way also. You can also use a tree structure to trace this recursion. We will talk about that tree later. Okay, for now, any doubt? Otherwise, we will move forward and we are going to learn something from problem solving perspective. Is there anyone who is having any doubt? Please feel free to ask. Okay, no doubt then. See, with recursion, there are some problem solving approach that comes. Okay, it comes in hand, and they exist with recursion only. Remember, you cannot apply these things without recursion. For example, first one, we have the concept of faith and expectation. When we will go and we will discuss about tree, graph, there these things will become very important. Okay, guys, just a moment. Hello. Hey, hi Rahul. 23. Yes. No variable. Oh. Mhm. Okay. Rahul, your voice is breaking. Yes, yes. Okay. Uh, okay. So, like, what's the best you can do? Mhm. Okay. Okay. I know. Yeah, that's actually very less. Yeah, something like that. Something like that. Because okay. Yes. Yes. Yeah. Yeah. Sure. Sure. Rahul. But then just one thing. Let's stay in touch. Career is very big. We'll see how it goes in the future. Okay. Uh, that's totally okay, but still, I mean, I am assuming you are also not going to stay with PwC for rest of your career, or are you? I am not sure. Sure, sure. Okay. Oh, okay. Okay, okay, sure, sure. Yes, 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 Rahul. Okay, all right. Okay, sure, sure. Okay, all right, all right. Okay. Uh, Thank you. PwC बोलो. सुनो ना, हम बोले दीदी का शाहिद का बर्थडे है ठीक है, दीदी बुलाइए जानो क्लास शाहिद का 200 कैश ही है मैंने क्या देख कैसे दिखा दिखा है है तो 200 रुपया कैश नहीं है. क्या करें हम 200 वो तो कल दे देंगे गिफ्ट कल ला नहीं नहीं फोन पे कर दूंगा. दीदी फोन पे कर दे. हाँ. दीदी कौन ले लेती है अरे है पैसा है क्या है. तो क्या हम फोन पे करेंगे पैसा. हाँ तो 200 कैश दे दो और बोलो ना कि दीदी 301 रुपीज फोन पे कर दो. हाँ 200 कैश दे दो और बोलो 301 रुपीज. कैश है कहाँ. अभी तो बोली 200 कैश है. नहीं है वही तो चाहिए हमको 200 रुपया कैश है ही नहीं. 200 दे देंगे ना अगर होता तो 200 है नहीं ना कैश. तो जाके निकाल लो नहीं है तो एटीएम में. पागल है मेरा फोन आया है 9 बजे कहाँ जाएगा. अरे यार तो जब नहीं जाएगी तो फिर फोन पे दे दो. दिक्कत है. अजीब लग रहा है फोन पे दे देंगे. तो ब्लिंकिट से कुछ ऑर्डर कर दो. तो बुलाया अभी तुरंत नीचे बर्थडे सेलिब्रेशन के बुलाने टाइम है उसमें. तो बोल दे कल सुबह गिफ्ट दे देंगे ना इतना अच्छा लगेगा. अच्छा नहीं लगता यार. बोलो ना दीदी फोन पे दे देता. चलो अभी उतना लंबा डिस्कशन मत करो जो करना था. Hey, hi guys. Sorry. Am I audible? Okay. And see, I can see only couple of you stays active in the class. That's very bad. I will break every single one of your head. Uh, please take it seriously. Hey, why she didn't join? Wait a minute. Okay, see, now we will move forward here. Of course, there is another one very simpler way to trace this recursion. There is something we call tree structure, but we will talk about that later. For now, there are couple of problem solving approach that comes with recursion. Very important, very powerful. Okay, and we will start with some simple problem itself. Here, let's say that I come to you and I tell you that given an array, or let's say given a string, it's the same thing. Let's talk about array only. Given an array, tell me if this is a palindromic array or not. Okay, so here, if I give you an array like this and I ask you that tell me if this is a palindromic array or not. Of course, you can solve it without recursion also. Okay, and you understand what I meant to say. Palindrome is something that remains the same from left to right as well as from right to left. If I read this array from left to right, I will read 1 3 4 5 4 3 1. And even if I read it from right to left, I will still read the same thing, 1 3 4 5 4 3 1. So this is a palindromic array. If I were to solve it without recursion, this is how we will do. I will put a pointer at the beginning of the array. I will put another pointer at the end of the array. I will check. If the values are same, then I will move I forward and I will move j backward. Okay, again, if the values are same, I will move I forward, I will move j backward. Again, if the value are same, I will move I forward and I will move j backward. Okay, and here also values are same. So if I do not find any irregularities, if I never find a value, a situation where I and j have different value, then I will say that it is not palindromic. If I have always found same value and if I and j becomes equal, then I will say that it is palindromic. It, for example, take this. I will put I here, j here. Then are the values same? Yes. So move I, move j. Are the values same? Yes. So move I, move j. Are the values same? No. So immediately I will say that it is not palindromic. But then let's say that this never happened. I never found a situation where I and j had the different value. And let's say that this increase and this decrease made I and j same. That same or cross, it's the same thing, because you see in this case if I move I one more step forward and j one more step backward, they will cross. So I will stop there, and if I never found a disparity, I will say that it is palindromic. How we are going to write the same thing programmatically? Like this. Okay, so let's say, let's create a file palindrome.java. Same thing you can do with a string also. This thing that I am doing with array, same thing can be done with a string also. Here, let's say that I have an array 1 3 1 2 3 8 3 2 1. Okay, and then let's say that I have a function that is returning me a boolean variable. Let's name this function is palindrome, and it is taking this array. Whatever is coming back to me, I am just printing it. So the only thing here is we need to implement this function. So let's quickly do it. Function, or you call it method, it's the same thing in Java. Here we will be implementing it one after another. Okay, now what was the logic? First I will put a pointer at the beginning of the array, another pointer at the end of the array, so something like this, arr dot length. And then I will say that as long as my I is strictly less than j, if the value that is present at these indexes are not same, okay, then in this case immediately return false. Okay, because if I find a, what should I say, inequality, I already got my answer. Think about this case. Let's say 3 2, 9. I will put I here, j here. The value themselves are not same. So immediately I got my answer. There's no need to check further. But then let's say that if they are same, then in that case you move your I forward and you move your j backward. Okay. Let's say that control comes outside of this while loop. So what I meant to say, let's say that control comes to line number 15. It simply means that you never found something like this. You never found a condition where this holds true. Okay, then only control will come outside. If this holds true even once, control of execution will return immediately because of this return. So control will never come at line number 15. If control is coming at line number 15, it simply means that you never found this. Okay, so if you have never found this, it simply means that it is a palindromic array, so you will return true. In this case, your output is definitely going to be true. Let's quickly verify. Okay, it should be arr.length minus 1. So my last index is arr.length minus 1. True. Correct. But then if I change my array, let's say that if I make it 20, now in this case I should get false. Let's quickly verify that also. Here. See, so this is a non-recursive solution of the same problem. And remember, whatsoever you can solve with recursion, you can also solve it without recursion. If something can be solved without recursion, it can also be solved with recursion. Is there anyone who is having any doubt in this implementation? So this is another problem that we have solved. Given an array or given a string, tell me if that a string is a palindromic string or not. This is how you can code it without recursion. With recursion, things become very interesting. Actually, the intuition becomes interesting. Let's take it on a string. If I come to you and I tell you that, okay, there is a string. Let's say this string is something like this, madam. Okay. Now the question that is being asked to you, that tell me if this string is a palindromic string or not. Without recursion though, we have already discussed the solution. Now let's try to solve it with recursion a little bit. See, there is a concept we call faith and expectation in recursion. Okay, we are going to use this particular concept to solve it. So we will start with this problem and we will solve at least 6-7 problems on this particular problem solving approach. Faith and expectation. Now how it works? Very simple. Let's say that you are given a problem and you have no idea on how to solve that problem. For example, this case. So we have a string and we want to know if this string is a palindromic string or not. Let's say that I literally have no idea how to do it. In that case, what I will do, I am going to write a method. Let's name that method is palindrome. Is palindrome. I will feed my problem to that method. And I will say that method, I have this blind faith on you. I have this faith on you that you will return me the correct answer. Okay, you will return me the correct answer. So I had a problem. The problem was to find out if this string is a palindromic string or not. And I am totally blank on how to do it. So what I did, I wrote a function and I feed my problem to the function, and now I am saying that Prabhu, I have this blind faith on you that you will return me the correct answer. Now of course this is not going to work like this. If I go and execute this method like this, I am going to get empty method exception. Okay, so you see, if you are even a little bit aware with Java, actually we had this here. Let's say that I have a method fun or fun t, and then let me just do something like this. Look here, unimplemented method. Okay, so there is an exception. The name is unsupported operation exception. Actually it's not an exception, it simply means that this method does not have any implementation. Okay, so if you execute a empty method, this is actually a empty method only with a throw keyword. So if you execute an empty method, you are going to get something like that only. Empty methods are not allowed programmatically, or maybe it is also allowed, I am not sure. In Python you might be able to do it with pass. Okay, so here whatsoever we had with unsupported operation exception, the same thing you can have in Python like this. Def, let's say that I have a method main, and let's say I do not want to write anything. In that case also I need to write something like this, pass. It simply means that this method is empty, but here you will not get any error. Okay, so here I have this blind faith. Now clearly this faith is not going to work like this. There, it's not exception, it's expectation. Faith and expectation. Expectation, okay. So when I had this blind faith on this method will come back to you and it will tell you that okay, I will satisfy your faith, but then there is a cost that you need to pay. What is that cost? This expectation. This method will have some expectation from you so that it can satisfy your faith. Same way we go and pray in front of God, they also have some expectation that we will be a good guy. Okay, now if you do not satisfy that expectation, in that case also faith will be satisfied in front of God, but here it's not going to be an optional thing. You will have to satisfy this expectation so that the method can satisfy your faith. Now what that expectation is, that makes it very, very interesting. This function will tell you that if you are not able to solve the bigger problem, solve the smallest one, not even the smaller one, the smallest one. For example, if I come to you and tell you that something like this, that given a string, tell me if that a string is a palindromic string or not, and I also tell you that this string is always going to be 1 in length. I am never going to give you a string that is more than 1 in length. Okay, so you don't need to know anything. You can directly say that if this string length, if this string length is less or equals to 1, I know for a fact that my answer is true. I am not able to solve the biggest problem, so I am solving the edge cases. Now why I wrote less or equals to 1? Because remember, programmatically a empty string is also a valid palindromic string, and it is definitely possible. Programmatically you can create a string that is having 0 length, empty string. Okay, so less or equals to 1 simply means either 1 or 0. It is never going, you cannot create a string that is having negative length. So again, long story short, I had a problem. I am totally blank on how to solve that problem. So what I did, I wrote a function, I feed my problem to the function, and then I am saying that function, I have this faith on you that you will solve this problem for me. Now this faith, it will come with some cost. The cost is to satisfy the expectation of this function. And what is the expectation? If you are not able to solve the problem, solve its edge cases. Edge cases, okay, technically we should call it like this, solve its edge cases. Now remember, there does not exist a problem in this world to which edge cases is going to be more complicated than this. No matter what the problem is, edge cases are always going to be a straightforward solution. It might happen that you might miss out on some of the edge cases. For example, in this problem itself, there is one more edge case. What is that? No matter how big your string is, if first and last characters are not same, it is never going to be a palindrome. So I can do something like this, that if str of 0 is not same as str of n minus 1, if first character and last character are not same, then I know for a fact that my answer is always false. For example, to this madam itself, if I put another A here and another B here, no matter what is present in between, this whole string can never be a palindrome. So remember, this faith and expectation is so powerful that sometime you might be able to write the logic even without knowing what did you wrote. You will only solve the edge cases and you will do something and it will work. Okay. I had certain scenarios where I didn't even understood the procedure completely, but I was able to code it using faith and expectation approach. Okay. It might happen that you will miss out on figuring out some of the edge cases, because clearly for every program it is not going to be this much straightforward. Okay, edge cases might come in some other form also, we will look at it, but then for this problem these are the only two things that we have. Now you see, once we are done figuring out and writing the code for edge cases, the next thing that you will have to do is you will have to find out a way to make a recursive call such that these edge cases will be met at some point. I told you at the very beginning, with recursion there are two things. First, you should have a base condition to break that recursion. Here I have multiple base condition. Okay, it's not like you will have only one base condition, you can have more than one also. Second, you should make your call in such a way that your recursion approaches that base condition instead of going away from it. Now in this case, think about it. Let's say that if we talk about this madam itself, here n value is 5. Is my n less or equals to 1? No. So this base condition will not match. If str of 0 not equals to str of n minus 1, that is also not true. The characters are same, both are yum. So we are done with these things. Now my answer depends on this. If this string is a palindrome, then my whole string is a palindrome. If this is not palindrome, then whole is also not palindrome. For example, if I talk about this, now length is 5. Is my n less or equals to 1? No. Is my characters not same? No. Characters are also same. So now my answer depends on this. If this is a palindrome, then I can say whole string is a palindrome. If this is not a palindrome, then I can say whole string is also not palindrome. So you see, I started with madam. Okay. And I said that I do not know how to write the logic. So I went to this function. I said that function, I have this faith on you that you will solve this problem for me. Function said pay some cost. I am done paying the cost. But again I am left with the same problem. Now I need to figure out if this is a palindrome or not. This is where faith and expectation become interesting. You need to solve for this. What you can do, you can say that if my function can tell me answer for whole string, it can also tell me answer for this. Okay, so I will go back to my function and I will say that function, see, I am done paying my cost. Now I had this faith on you. So if that faith holds true for whole string, it also holds true for this. So from index 1 to index n minus 2, please tell me if this string is a palindrome or not. If this is a palindrome, then return true, otherwise you return false. Do you remember this? Do you understand this code, every one of you, what is happening here? How I have applied this analogy of faith and expectation on this problem? So there are mainly two steps. First, you need to figure out your base cases, and second, you need to make a recursive call in such a way such that that base case, that call approaches your base case. For example, here you see, for madam, initially I will make a call for madam. Now if n less or equals to 1, no. Is my characters not same? No. So next call that will be made is for ADA. Now again, is my n less or equals to 1? No. Are the characters not same? No. Characters are also same. So next call will be made for D. And then here I will encounter this condition, I will return true. So it will return true here, it will return true here, and then it is going to return true to its caller. Do you understand this, every one of you, how I have coded it? Now let's take it on a string that is not palindrome. For example, if I call it on this string, then you will see that the same analogy can be used to solve very complex problems also. let's say that I take out this. Now again, n clearly not less or equals to 2, less or equals to 1, and characters are also not same. Characters are same actually. So the next call that will be made is for x, y, z, w by x. Now again same story. Is my n less or equals to 1? No. Are the characters not same? No. Characters are same. So the next call that will be made is for y, z, w, y. Now again, is my n less or equals to 1? No. Are my characters not same? No, characters are also same. So the next call that will be made is for this. Now again, is my n less or equals to 1? No. Are the characters not same? Yes, character at index 0 is not same as character at n minus 1. You see, n is also changing call to call. In this case, my n is 2 to 4 to 6 to 8. In this case, my n is 6. I am evaluating n at every call. In this case, my n is 4. In this case, my n is 2. So 0 and 1, are the characters not same? Yes, it is not same. So it is going to return false here to its caller. Then again this caller will return false here. Then again this caller will return false here, and then whoever called it, the false will be returned there. Do you understand this, every one of you? So you need to focus more on the analogy, how I am trying to fit this faith and expectation into this code. Is there any doubt, any one of you, any concern, anything you want to ask, anything you want me to repeat? Please feel free to ask for help. Anyone? All right. So let's quickly code it, and then I think we will be done for the day. No, we will code it. It will be very quick, like just one moment, and we will be done. Here, चुप हो जाओ यार. Just one moment. Is there anyone who is having any doubt? No. See, it's just 3 lines of code, okay, and I will be very quick. Within next 5 minutes, we will be done. For example, here itself, let's say that I have a string. Take a string like this. Madam. And now I need to know that if this string is a palindromic string or not. So what I will do, I am going to have another variable answer2 equals to is palindrome, let's name it 2, and it is going to receive a string. Okay, now same code, we have already coded it. Let's quickly write these things here also. So we will apply faith and expectation. I will say that I don't know how to write the code, so I have this blind faith on this method, and then everywhere I am first going to evaluate the length, str.length, and then I will say that if my n value is less or equals to 1, in this case please return true. Okay, first base case. Second base case, if my first and last characters are not same, so if char at 0 is not same as char at n minus 1, okay, char at n minus 1, in this case I will return false immediately. Otherwise I am just going to ask the same question again, that can you please return this is palindrome of from first index. So str dot substring of from first index to n minus 2 index. So you see I will write n minus 1 here, because str runs from a start to end minus 1. Why is this producing error? Is palindrome of 2. Okay, is palindrome of 2. So you see, if I use substring like this 1 to 5, it is going to run from 1 to 4 only. I want to run it till n minus 2, so I will write n minus 1 here, and then we are done. So let's quickly print out this answer 2 also, and let's see if it works or not. There's no error at all.
सर वो पैलिंड्रोम की स्पेलिंग अलग अलग है ऊपर.
There's That's just a editor glitch. अरे यार क्या दिक्कत है इसको.
तो जहाँ पे आपने बूलियन आंसर टू इस पैलिंड्रोम टू लिखे वहाँ पे पी ए
For type name is palindrome. Okay, let's quickly have a look. It's so we should get our answer 2 as true. Okay, true. And then let's say that if I change it to kit, I should get it now false. Let's have a look. All right, so I think this will be sufficient for today. Should you have any concern, any doubt, any one of you, please feel free to ask for help. Recording, code, all of these things I will give you once I am done stop recording it. Okay, but then if you have any concern, any doubt, please feel free to ask for help quickly. Otherwise we are done for the session. All right then. Thank you very much, guys. I will see you again tomorrow. Okay. Next week we will have everyday class, like whole 5 6 days we will be having sessions. Okay. Thank you very much. This will be enough for today. Bye bye. Good night.
सर
Wait.
आप सुन तो लो.
It was done. Recording. Oh God, I was not recording it at all.
हो
Wait. Ah, yes, yes, yes.